Hello, students. I'm going to talk a little bit about graphs of polar equations. If you did this first or the Desmos activity first, it doesn't really matter the order. I'm just going to go over a few extra little things on how you could do this with the calculator, etc. You're going to be assessed with this through that Desmos activity. Your answers to the questions, the answers to the graphs is how you'll be assessed on these graphs. Those of you planning to take BC calculus, or if you're just interested and curious, I will be making another video on how to graph these without a calculator so that you're aware of how to do that for BC Calc or Calc 2. So first of all, there's circles. R equals A is a circle centered at the origin. R equals A sine theta and R equals A cosine theta are centered either on the X or the Y axis. So R equals A sine theta, and R equals A cosine theta all are circles. Another one is called a rose. They look more like flowers than necessarily a specific rose, but they're in the form R equals A sine n theta and R equals A cosine n theta. If n is odd, there's exactly that many leaves. If n is even, there are double the number of leaves. So that first graph here, this number one graph, let's see if I can get my pen working. This first graph right here is has 4 petals on it, is what they're called, or leaves, and so that n would be 2. This middle one right here, the second one, has 3 leaves, so I know that that n is 3. If you watch my video on how to do this without a calculator, I'll kind of show you why there's a double amount of leaves or not, depending on what kind it is. The last one is called a limnason. I missed the little tilde or whatever it is on the C up here. I couldn't find that symbol when I made this PowerPoint. It is a French word, limnason. Some of them are flat along the bottom, like the first one. Some of them have a loop, and some of them have a little, what's called a dimple. Right now, you'd be laughing if we were talking about this in class, but that's what they're called. Sometimes this last one is called a cardioid as well. To tell whether these things have loops or not is if which one is it going to be? A needs to be smaller than B, then there should be a loop. I always forget. I have to do them by hand to figure that out. And I think that is right. Let's think here. So that's how they have a loop, and I can show you that in the non-calculator one. Maybe I'm showing you enough of why you need to go in there. And then the last one is called a spiral. It's just A theta, and it would just go out. It would just get bigger and bigger and bigger, because once you multiply this by your angle by A, it just gets bigger and bigger and bigger. So that is the last. So moving on, let's just look at the calculator a little bit. So in order to put your calculator into polar mode, you go to mode, and down here there's something called a function. We want to switch that over to polar mode and hit enter. Now when you go to y equals, it is in r equals instead, because it's now in polar mode. Let me get rid of these plots from whatever I had it on in stats. So if you want to enter r equals like 3 sine theta, now this x comma t comma theta comma n button, once you actually hit it now, it's actually a theta. Usually kids are excited about that when we do that in class, because they thought that was just the x button. But there's a reason that there's 4 variables on there. Each different mode of your calculator uses a different one. And now if you hit graph, let me hit zoom standard because I don't know where mine's at. You'll see a circle. It may look a little oval-like, but that's because the y-axis is a little smaller ones than the x-axis, if you can tell. If you want it to look actually circle-like, you go to zoom, and then you go down to number 5, which is zoom squared. And then it'll look like a circle. When you're graphing these for me in class, if we were to go back to class and we were to do any of these, you could use the table. Let me check a few things. Let me check that we're in degree mode. Oh, we're in radian mode. Let's switch that to degree mode. And I'm going to go to my window. I want theta to go from 0 to 360. I'm going to have it graph every 1 degree. And then I think that should work. So let's see. 1 degree makes it graph fairly slow, but I think that'll work just fine. The other thing you have to watch out for is your table. So once we go into our table, I still have it set in degree mode, but I believe I can hit plus from here and change the table. I want it to go by 15 degrees. I apologize for any background noise because apparently my son is upstairs playing the piano and they were thumping around earlier. We'll go with whatever. I apologize for any background noise you hear, but I'm not re-recording this. Okay, so I'm going to change my table setup to 0 and go up by 15s. So if you were to have to graph this, you can see the main points. You'd graph 0, 0, you'd graph 0, 3. If you wanted any more points, you could use the table and do it like a unit circle. We'd ignore 15, but we do 30 and we'd go out to 1.5. 45 would be 2.12. 60 would be 2.5. We'd ignore 75. That's not on a unit circle or on a polar graph. And then we go from 90 to 300. So you can use your table to figure those out. Let me just double check the 2 plus 3 sine theta should make a limnason with a loop. Let's graph it and see. Here it goes. I think I'm going to send a text to my husband to tell Chris to be quiet. Oh, it's working. So there is a loop right there because the 3 is bigger than the 2. So for the most part, for what you're going to be able to do, you can do this in Desmos too, which there is an activity there for you to kind of play around with this and see what changes everything. But that is the basics on the calculator. Stay tuned. Feel free to watch the other video if you want to know how to do this without a calculator.